Shanting with the commentary number is DE180047. So for today, me and my group members, which is Mesuna, are going to present about the assignment 2 for the subject BEJ 34202 Vision System. We are from section 1.
My name is Mishna Kanti Permal and my metric number is DE180011. And now I will present about introduction. Recycle is to use the thing again but in a different purpose. Recycling is the important part of environmental and economical aspect because to maintain an effective recycle system and to separate the recycled materials are needed. CNN is a class of deep neural network and most commonly applied to analyze visual imagery. The pre-trained model that we use in this project are CNN, VGG16 and ResNet. VG16, also known as Oxford Net, in a conventional network architecture that has 16 layers deep and can load a pre-trained vision of the network trained on more than million images from the image network database. ResNet is to solve the problem of vanishing gradient in deep neural network by allowing this alternate shortcut path of the gradient to flow through. Objective of this project are to design the CNN model to train the data without overfitting and underfitting using Google Colab. And the second objective are to analyze the performance of the CNN models. And the third objective is to design the pre-trained data and analyze it using Google Colab.
I'm going to continue to present about the methodology for this assignment. First, we are using CNN models in completing the task 1. So in order to fulfill the requirement, we need to design our own CNN models to train the data without overfitting or underfitting. So we need to use the pre-arranged data for training and validation, which is given by the lecturers in the Google Drive link. And then we need to take the photos of aluminum cans and the PETS bottle as well. So for the task 2, by using the transfer learning concept, we have to repeat the training process and find the optimal model, such as VGG, ResNet, and extra. So for this case, we are going to do it by using VGG model and ResNet model. Continue the methodology with this flowchart. First, we have to loading the data from the Google Drive, and then we have to training the samples, and then convolution layer and max pooling for 3 times, and then dense, and then we get a CNN-based feature learning network to get the training sample features, and then last we get the image classification to get the output classification result. This is the overall flowchart for this project. And then here there are some steps of VGG and ResNet model. So first we have to connect the Google Colab to our Google Drive, and then we need to feed the dataset directory. Third, we need to create train and validation data directory. 4, we need to construct the pre-trained model with VGG or ResNet. And then number 5, pre-process the input data, which is rescue the image by 1./255 and resize the image into 150 times 150. So we need to start the training process, which is the epoch we set as 10. You may set as high as you can if you want. And then number 7 is plot the outcome. So we'll get the graph here.
Now I will show you the demonstration of CNN model using Google Colab. So first we need to connect to the Google Drive. So for the connect we need to play this, and we will get a link, so we need to paste here. And the second step is feed data set directly, so we just play this. So third step is create train and validation data directly. So for that we need to copy the part from our Google Drive and we just paste here. So after pasting all the part, we just play it, and it will show the number here, the number of can train length, pet train length, can ventilation length, and pet ventilation length here. So after that we play this is to import the library from Google Colab, and after that we construct the CNN model. So we play this. Okay, we will get this, and for the total parameter is 19034.177, and the train parameters is 1903.4177, and this is show it is non-trainable parameters. So for step 5, we pre-process the input data. So it shows here belongs to two classes, and data batch shape is 20, 150, 153, and label batch shape is 20. So for start training process, we are, as you see here, this is the code here, coding, and this echo part is 10. So we play this, but this take more than few minutes, so we have to wait for this to end. So it's for now it running for 1, so we need to wait until it finish 10. So it takes time. Okay, after this epoch finish, it shows that the loss and accuracy of the images. So for the for the accuracy, it shows 0.6803 and the ventilation losses is 0.5836. so this is all the echo pop. So after this, we'll plot the outcome here. It will plot a graph. So this is our graph for the train and ventilation losses. So this is the ventilation loss, and the dot is the train loss. Okay, for step 8, we feed the sample image to observe which pad and can is dominant. So for can stay and pad move further backward is this image. This is the image, this is the can, and this is the pad here. So for this image, we will run, and this shows that this image is 100% can and 100% pad. So for the second image, the pad and can stays at the same distance from the camera. So same distance from the camera is this. Okay, this is can and pad at the same distance from the camera. So we play this, and this shows that the image 100% can and 100% pad. So pad stays and can move further backward this image. So for this we play. Okay, this shows this image is 100% and the can and 100% pad.
Now I'm going to run the simulation for the task 2, which is by using the VGG model. So step 1, we need to connect to the Google Drive. This is the coding, and then we click the play, and then we need to access to the Google link, and then we get the authorization code from the link. Then we paste in here, then we can run, then we can get it to connect with the Google. So next we need to feed the dataset directory. So first of all, you need to check that your data is inside the Google Drive. Okay, so I'm saving this in Colab notebooks, and then recycle file with the train and val and test file. Okay, so the third step is create train and validation data directory. So this is the coding, and then we can get the output is can train length is 156, pad train length is 310, and then the cat val length is 77, and then pad val length is 133. Okay, that one is for the step 3. And then for we need to run this coding to import the TensorFlow SDF. Okay, so for the step 4, we need to construct a pre-10 model with VGG. So as usual, we run the code and we'll get the parameter of this process. So the total parameter for this process is 18,910. All right, so then we go to the step 5, which is pre-process the input data. So we'll found that 466 image belonging to 2 classes, and then we found that 210 image is belonging to 2 classes. So the data batch self and the label batch shape is shown at here. So we start our training process. The epoch we set is 10. The step per epoch is also 10. The validation step we also set as 10. So as you can see, this take up quite a lot of time. Such estimate is more than 15 minutes. Then we'll get the graph here. So this is the graph that I run for third time to get a nicer data. So this is the point that the highest point and the point that we get to see the val accuracy and the loss accuracy, the loss data of this task. And I'm going to show the simulation of task 2 again, but this time is by using the ResNet model. So the step is same as the previous one, which is we need to connect to the Google Drive, we need to feed the data directory, we need to create the train and validation data directory. So basically until here the data, the output that we get is the same. Okay, so until the step 4, step 5, so you can see the image that they found, the data batch shape and the label batch shape is same as the previously. So the most important part is the training process. For this ResNet, I'm using step per epoch is equal to 10 as well, the epoch is equal to 10 as well, and the validation step is equal to 10. So for this step, take around 20 minutes to run. Okay, so lastly we'll get the graph, which is the outcome. So this is the graph that I run for the third time as well. So I get this output for the ResNet. Okay, so you can see the overall the val loss time, the validation loss time is higher than the training loss time, and then the accuracy, the most accurate is the highest is the 0.38. So that's all for the simulation for this part.
Okay, the discussion of this project is in this group. Our group has choose 3 patent model, which is CNN, VGG16, and ResNet. The student should be able to learn on how to convert neural network using Google Colab and also run an algorithm which is a program comment on Spider in Anaconda software. Commanding transfer features which is VGG16 and ResNet from multiple CNNs could improve the classification accuracy. We learn how to obtain the result using VGG16 and having higher accuracy as compared the result of training without pre-trained model. Thank you.
To the conclusion for this assignment, transfer learning is mostly used in computer vision and natural language processing tasks like sentiment analysis due to the huge amount of computational power required. So transfer learning has several benefits such as saving training time, better performance of neural networks in most cases, and not needing a lot of data. Next, we have gained a lot of ideas on solving the problem in classifying the types of waste material in our daily life, which is our topic for this assignment. With the implementation of the function of vision system in solving the issue that facing by everyone, it is indeed a great idea and it helps to save a lot of time. Last but not least, we are able to run the coding and get the outcome successfully in this task given. Lastly, we are also able to identify the accuracy and the loss of the data by using the convolution neural network in this assignment. That's all from our group. Thank you.